Here we have the project repository, ready with the complete codebase provided by our development team. In this demonstration, we'll deploy this application using modern DevOps practices. We'll use AI to containerize the app with Docker and to create a continuous integration and deployment pipeline. This pipeline will build the Docker image, push it to a container registry, and finally deploy it so we can run it locally. Next, let's see how AI can guide us through the deployment process step by step. First, it helps us prepare the Dockerfile NGINX configuration to containerize our application. Then, AI generates the GitHub Actions workflow for continuous integration and deployment. After that, it automates pushing the Docker image to the GitHub container registry. Finally, AI shows how to pull the image locally and run the container, completing the full deployment workflow effortlessly. In this step, we add all the necessary files, including the Dockerfile and NGINX configuration, into our GitHub repository. These files form the foundation for building the Docker image and deploying the application. With everything in place, we're ready to move on to automating the build and deployment process. Next, we use AI to create the continuous integration and deployment pipeline and add it to GitHub Actions. This workflow is fully automated. It builds the Docker image, tags it, and pushes it to the container registry. With this pipeline in place, every time we push code, the workflow runs seamlessly, ensuring the application is always ready to be deployed with minimal manual effort. Here we can see the pipeline in action, illustrating how the entire deployment process works. Everything is fully automated, from building the Docker image to pushing it to the container registry. This ensures that each code update is deployed efficiently and consistently, without any manual intervention. Now let's look at how we can extend our workflow to deploy what we build into the Kubernetes cluster, and we'll make use of AI to simplify it. We'll start by allowing the cluster to pull images from GitHub using a registry secret. Then, we'll add our kubeconfig as a GitHub secret so the workflow can connect securely to the cluster. Next, we'll prepare the Kubernetes manifest with the namespace, deployment, and service definitions. Finally, we'll update the GitHub Actions pipeline to build the image, push it to GHCR, apply the manifest, and roll out the app automatically whenever we push to main branch. Here's the pipeline we've added. It's designed to handle the entire continuous integration and continuous deployment process efficiently. The GitHub Actions pipeline is now running. It first checks out the latest code, logs into GitHub container registry, and builds a new Docker image for our app. Once the build is complete, the image is pushed to GHCR with both a latest tag and a unique SHA tag. Next, the workflow connects securely to our Kubernetes cluster using the kubeconfig secret we added earlier. It automatically updates the deployment manifest, applies it to the Nova app namespace, and triggers a rollout. Within moments, the new pods are created, the old ones are replaced, and our latest version is live, fully automated, from code push to running in the cluster. Now, let's verify the deployment. We'll use a simple port forward command to connect our local machine to the service running inside the cluster. Once the command is active, we can open the browser and visit localhost 8080 to see our application live, deployed straight from the pipeline to Kubernetes. Everything is working perfectly, and that completes our automated deployment workflow. Thank you for watching this video on deploying our sample application using an automated CI/CD pipeline. We've successfully built, pushed, and deployed the app to Kubernetes.